Hello guys, welcome back to my channel. We are now in session 4 of pair of straight lines. There's one more session left. This is the fourth one in the series of 5 sessions. So here today we are going to discuss some questions based on the theorems that we learned, some concepts that we learned in the earlier videos. So let's not waste any time and let's begin. So the first question I've taken, it's a very simple question. The question says, find the joint equation of a pair of lines passing through -1, 2. One is parallel to x plus 3y minus 1 equal to 0, and the other is perpendicular to 2x minus 3y minus 1 equal to 0. So we have to find the joint equation of a pair of lines. It's passing through point -1, 2. Both the lines are passing through -1, 2. One of the lines is parallel to this line and the other line is perpendicular to this line. So let's look at the solution. We start with assuming the first line to be L1, and that is a line which is passing through obviously this point -1, 2, and it is parallel to this line x plus 3y minus 1 equal to 0. Now what is the slope of x plus 3y minus 1 equal to 0? The slope is minus a by b. We've already discussed that earlier. So -1 by 3. So the slope is -1 by 3 here, and obviously because our required line L1 is parallel to this line, the slope of parallel lines, you remember, is equal. So -1 by 3 will be the slope of our required line L1 as well. Using this slope and this point -1, 2, we'll find the equation of line L1. That's fairly simple. Y minus y1 equal to m into x minus x1. So I've just done that, and I've got x plus 3y minus 5 equal to 0 as the equation of line L1. So this is the separate equation of line L1. Likewise, we are going to find the equation of line L2. So again, the line L2 is passing through -1, 2, and it is perpendicular to this line 2x minus 3y minus 1 equal to 0. Obviously now here in this case the slope is -2 by -3, which therefore would become 2 by 3. And you know that our required line L2 is perpendicular to this line, so it will be the negative and reciprocal of 2 by 3. The slope will be -3 by 2. Using the slope -3 by 2 and the point again -1, 2, we'll get the equation of line L2. Okay, again by slope point form, y minus 2 equal to -3 by 2 into x plus 1. So that's y minus y1 equal to m into x minus x1. You get the equation after simplification as 3x plus 2y minus 1 equal to 0. So this is now the separate equation of line L2. Now we had to find the joint equation of those two lines, line L1 and L2. So the joint equation is what? It's basically just the first equation of L1, x plus 3y minus 5 equal to 0, multiplied by 3x plus 2y minus 1 equal to 0. Here they are. You just open out the brackets, just multiply every term correctly, collect the terms. You'll get 3x square plus 11xy plus 6y square minus 16x minus 13y plus 5 equal to 0. You just need to multiply these two brackets carefully, collect the terms, and you will get your answer. Let's move on to the second question. Now the second question says, find the separate equations of the lines represented by, and then I have taken two examples for the same. So in the earlier question we were combining two lines and making a joint equation. Now they've given you a joint equation and we have to find the separate equations. Okay, so let's take the first one. The first one is 3x square minus 10xy minus 8y square equal to 0. Now you just need to be able to find the factors of the quadratic equation. This is a quadratic equation. You have 3 multiplied by -8, which means you need a product of -24, and there is a sum or a difference of -10. So obviously we are looking at -12 into 2, which gives you -24, and also -12 plus 2 gives you -10. So we break this -10xy as -12xy. Sorry for the overwriting there. -12xy plus 2xy minus 8y square equal to 0. You just take 3x common, this comes here, then between these two we take 2y common, you get this again. X minus 4y is taken common, you get 3x plus 2y in the other bracket, which means x minus 4y will be one equation, 3x plus 2y will be the other equation, and these are the equations or the separate equations that are required of this joint equation. Then moving on to the next question. Now in this case you have x square plus 2 cosec alpha into xy plus y square equal to 0. Now we cannot factorize this because you don't have any proper numbers here to factorize. So what we do is we convert this into the auxiliary equation. Remember we had discussed the auxiliary equation in the second video of straight lines. What is the auxiliary equation? The auxiliary equation is basically just divide the whole thing by x square and you write y by x as m. So what will happen is y by x whole squared would become m square, 2 cosec alpha, and this xy upon x square would become y by x, that would become m, and x square upon x square would become 1. So that's m square plus 2 cosec alpha into m plus 1. Now that's a quadratic equation in m. So let's find m by the formula method. You know the formula method, minus b plus minus root of b square minus 4ac upon 2a. That's something that we have done in school. So you just insert the terms in the relevant places. So minus b, so that will be minus 2 cosec alpha, plus minus root of b square, so 2 cosec alpha would become 4 cosec square alpha, minus 4ac, so that's 4 into 1 into 1, yeah, and upon 2a, so 2 into again this a is 1, and so we just simplify this. Remember, you'll take 4 common, so that comes out of the root as 2. Cosec square alpha minus 1 will become cot alpha. This 2 and this 2 is taken common and cancelled with this 2. So you're left with an m, which will be minus cosec alpha plus minus cot alpha. So the separate equations of this joint equation will be what? They'll be of the form y equal to mx, right? Because this is a homogeneous equation of second degree in x and y. It is representing 2 lines passing through the origin. So obviously the 2 lines will be of the form y equal to mx because they are passing through the origin. So what will be the separate equations? One will have the m with this plus sign and the other will have the m with the minus sign. So you will have y is equal to minus cosec alpha plus cot alpha into x, and the other line will be y is equal to minus cosec alpha minus cot alpha into x. So that's the second sum. Let's move on to the third one now. Now the third question says, find the joint equation of the pair of lines through the origin which are perpendicular to the lines represented by 5x square minus 8xy plus 3y square equal to 0. Now remember what is the question now. Understand, you want to find the joint equation of 2 lines which are also passing through the origin and they are perpendicular to these 2 lines. So there will be there are 2 lines that we are trying to find. There are 2 lines inside this equation. One line is perpendicular to one of the lines, the other line is perpendicular to the other line in this equation. That is what we are looking for. So how do we start? So we take this equation 5x square minus 8xy plus 3y square and we compare it with your homogeneous equation of second degree in x and y to just get the values of a, 2h and b. So what is a is 5, your 2h is minus 8 and your b is 3. Alright, now what we'll do is we'll say let m1 and m2 be the slopes of the lines represented by 5x square minus 8xy plus 3y square equal to 0, meaning the given lines have slopes m1 and m2. Alright, so you know the sum of the slopes and the product of the slopes formula. M1 plus m2 is minus 2h by b, m1 into m2 is a by b. So m1 plus m2 will be minus 2h by b, means minus of minus 8 upon 3, so that's 8 by 3. m1 into m2 is a by b, which means that is 5 by 3. Alright, here you go, that's 5 by 3. Now you know your required lines are perpendicular to these lines whose slopes are m1 and m2. So what do you think will be the slopes of the required lines? They're perpendicular, right? So negative and reciprocal of m1 and m2 would be minus 1 by m1 and minus 1 by m2. Now you know that these lines are passing through the origin. That has also been, the required lines are passing through the origin. That is also given in the sum. So what would be the separate equations? One would be y is equal to minus 1 by m1 into x and the other would be y is equal to minus 1 by m2 into x. Just simplify this. m1 goes there, m1y, and this minus x will come here. So x plus m1y equal to 0 and x plus m2y equal to 0. That would be the two separate equations of your required line. Then we combine those two. You take x plus m1y equal to 0 and x plus m2y equal to 0 and combine them. So x plus m1y into x plus m2y will multiply. So when we multiply, you'll get x into x square. You'll get m2xy plus m1xy, where we've taken xy common, m1 plus m2 in the bracket, and then there is m1 m2 y square, which comes here, equal to 0. Now you know m1 plus m2 value, and you know the m1 into m2 value. We've just found it over leaves, so that's 8 by 3 and 5 by 3 respectively. Simplify this, you get 3x square plus 8xy plus 5y square equal to 0, and those are your required, that is your joint equation of the required lines. Moving on to the fourth question. Now this is a simple question. Find k if the slopes of the lines represented by 3x square plus kxy minus y square equal to 0 differ by 4. So your slopes of these lines are differing by 4. We have to find this unknown k in the equation. Again, when you compare it with the homogeneous equation of second degree in x and y, you get a as 3, 2h as k, and b as minus 1. Again, we say let m1 and m2 be the slopes of these lines. We find the sum of the two slopes. We find the product of the two slopes. m1 plus m2 is minus 2h by b, so that is minus of k by minus 1, so that is k. m1 into m2 is a by b, which will make it 3 by minus 1, and that will become minus 3. Now we again, since they've told you that the slopes differ by 4, we know m1 minus m2 is 4. So we need to now use m1 minus m2, m1 plus m2, and m1 into m2, and get that equality which we had used in the third theorem. m1 minus m2 whole squared is equal to m1 plus m2 whole squared minus 4m1 m2. Substitute the relevant terms in place. So m1 minus m2, you know they're differing by 4, so you'll substitute 4 there, so 4 square. m1 plus m2 is k, so we substitute that, that's whole squared, so k square. Then minus 4 into m1 into m2 is minus 3, so minus 4 into minus 3 is plus 12, so 16 is equal to k square plus 12. K square is equal to 4, which would mean k is plus or minus 2. A very simple sum. Now let's come to the sum, the next sum, the fifth question. Find the condition that the line 3x plus y equal to 0 may be perpendicular to one of the lines given by ax square plus 2hxy plus by square equal to 0. Okay, so what we do is we first of all say let the auxiliary equation of the lines represented by ax square plus 2hxy plus by square equal to 0 be, and we know what that is, right? Bm square plus 2hm plus a equal to 0. We've discussed this in the second video, the second session of pair of lines. So bm square plus 2hm plus a equal to 0 is the auxiliary equation. You know one of the lines that are there in this equation. There are two lines, right? There are two slopes in this equation. So one of the lines is perpendicular to the line 3x plus y equal to 0 here. Yeah. So your one of the lines is perpendicular to 3x plus y equal to 0. What is the slope of 3x plus y equal to 0? It is minus 3 by 1, which will be minus 3. Obviously the slope of one of the lines in this equation will be 1 by 3, negative and reciprocal of this, because your required line is perpendicular to this line. So minus 3 ka ho jayega 1 by 3, negative and reciprocal. This 1 by 3 is definitely a root of this auxiliary equation, right? And so it will satisfy that auxiliary equation. You will substitute m as 1 by 3 in this auxiliary equation. You'll simplify. Here you go. Here's the simplification. You just put 1 by 3 in place of m everywhere and simplify, and you will get b plus 6h plus 9a equal to 0, and that will be your required condition. The question was just find the condition for this line to be perpendicular to one of the lines given by the joint equation. That was a very simple question. Anyways, let's come to the next sum. Alright, now this is now the sum based on your third theorem. The question is find the measure of the acute angle between the lines represented by 3x square minus 4 root 3xy plus 3y square equal to 0. So we'll just compare it with ax square plus 2hxy plus by square equal to 0, and we will get a as 3, we'll get 2h as minus 4 root 3, and b as 3 again. Alright, Now, we know from the third theorem that the angle between a pair of lines passing to the origin is given by tan theta equal to 2 root h square minus ab upon a plus b. We have to just substitute these terms at the relevant places. So 2 root, and in place of h you will have obviously minus 4 root 3 divided by 2, because you have to substitute h, not 2h. So that's minus 2 root 3 whole squared, minus ab is 3 into 3, so that's 2 root 12 minus 9. Remember, minus 2 root 3 square is 12, because that's 4 into 3, 12 minus 9. And you have 3 plus 3, 6 here. So 2 goes in with 6 3 times. You have a root 3 by 3, which gives you 1 by root 3. So tan theta is coming to 1 by root 3. So theta is tan inverse of 1 by root 3, and 1 by root 3 is a standard value. Remember, if this was a non-standard value, say if you would have gotten a 5 or something over here only, tan theta equal to 5, then theta would be just simply tan inverse of 5. We would just leave it that way. But now, since 1 by root 3 is a standard value, you know that tan of some angle is 1 by root 3, which you know is 30 degrees, or you can even write as pi by 6 radian. And that is how you do this sum. Now, let's come to the seventh question, the last in today's video. Now, the question is, find the joint equation of the pair of lines through the origin, each of which is making an angle of 30 degrees with the line 3x plus 2y minus 11 equal to 0. Now, how do we start? We just first of all find the slope of the line 3x plus 2y minus 11 equal to 0. What's the slope? The slope is minus 3 by 2. Minus 3 by 2. Yeah, so we call that m1. Then we say let m be the slope of one of the lines making an angle of 30 degrees with this line. That's what the question says. We have to find the joint equation of the pair of lines, yeah, through the origin, each of which is making an angle of 30 degrees with this line. So we are assuming one of the lines to have one of the required lines in the joint equation, the slope to be m for that, and it is making an angle of 30 degrees with this line, whose slope now we've just found as minus 3 by 2. Okay, so you know the formula that we learned in 11th standard, that tan theta is m1 minus m2 upon 1 plus m1 m2. We are using that formula. So in place of theta we put tan 30, then in place of m1 we are putting m, then in place of m2 we'll just substitute this minus 3 by 2 upon 1 plus m1 m2, so that's m into minus 3 by 2. So we just write the value of tan 30 as 1 by root 3. We just simplify this a little bit. We take LCM, 2m plus 3 upon 2, 2 minus 3m upon 2, 2 gets cancelled as the LCM. Here we then square both sides. 1 by root 3 becomes 1 by 3. This mod goes away because now we're squaring, so there will be positive only. We don't need the mod. Then we just open this out, sorry. We open this out, cross multiply, and we end up with the 3m square plus 48m plus 23 equal to 0. What is this? This is the auxiliary equation of that required joint equation, right? And so we then substitute m as y by x. We put that m ke jagah pe y by x. So 3 into y by x whole squared plus 48 into y by x plus 23 equal to 0. Simplify that, multiply throughout by x square. You get 23x square plus 48xy plus 3y square as the required joint equation. So this was part 1 of the sums. There will be one last video that I'll come up with where I will do the remainder of the sums. I hope you enjoyed the video and you understood all the sums. See you again next time. Bye bye.